This is Professor Pelton. This is part 3 of chapter 3, section 7. So now we go to the horizontal line test and talk about one-to-one. So not every function has an inverse, so you might need to restrict the domain and ranges, or specifically the domains, which is the range of the inverse, to actually make a inverse function. So first off, if a function f has an inverse, then no horizontal line intersects the graph at more than one point. Okay, thus the function must be one-to-one, which means when you do the mapping, every element of the range is exactly one element of its domain. So if I look at the following, which of the following is one-to-one, and which of the following has an inverse function? So these are both functions, right? So for every input, there's exactly one output. So these are both functions, right? However, not both of these are one-to-one. So this one is one-to-one. Okay. This one is not one-to-one. Okay. Because we have two things mapping to one item, right? So the range is mapping to two elements in the domain, so it's backwards. So it is a function, but is not one-to-one. So as a result, the inverse exists. And in here, the inverse does not exist. Okay, that's the basic idea. Okay, so determine the mapping of the inverse G. Determine if the inverse of G is a function. Determine if G is one-to-one. All right, so if I switch the values A, B, C, 1, 2, 3, okay, then what am I going to get? 1, 2, 3, A, B, C. Let's make sure I did that correctly. So A maps to 3. 3, oh, no, I did not do that right. Let's try that up again. No, that does not work. Sorry. Okay, so in the original, A maps to 3. So in this one, 3 maps to A. That works better. And the other one, B maps to 1. So therefore, 1 maps to B, right? And then accordingly, C maps to 2. So then 2 maps to C. Okay, so that actually works. All right, so is G one-to-one? This is one-to-one. It is, right? Because the inverse is also a function as a result. So the original is a function and the inverse is a function. So it actually works. Okay, so let's try. I'll have you try one more. Pause the video, try the student problem. So determine the mapping of the inverse of g of x. Determine if the inverse of g of x is a function. Okay, so we'll switch them up here. All right, so we'll put the values of 16, 4, and 0 over here. Then we'll put the values of -4, -2, 0, 2, and 4. Okay, so if I map this, 16 maps to -4, and 16 maps to +4. 4 maps to -2. 4 also maps to 2. And 0 maps to 0. Okay, so this is not a function, right? So if this is supposedly G inverse, it's not a function because for every input, right, there's more than one output in several cases, so it's not a function. And this is not one-to-one. Okay, that's why one-to-one is important, because if it's not one-to-one, it's not the inverse is not a function. Okay, determine if the inverse of gx is a function. No. All right. So that is the end of part 3.